Welcome back to week 3, test number 2 for geometry. We have our trigonometry quiz is going to be occurring. It's our week 2 task. So we have a review here that you can go over and complete before you take your quiz. You do not need to watch the entire video. I'm going to kind of go over some instructions, talk a little bit about the quiz here before I get started, but then I will go through each problem individually, problem by problem, all the way through the review, and you can check and see as you want. So I would recommend you here pay attention here to the introduction. One thing, and then what I will show you is how you can just skip around. Now, if we go to Schoology, so what we've got here is this is week 3, task 2. You can print the blank notes. See my mouse here, clicking on blank notes. That's the review. If you can complete that review, you will be prepared to take the quiz. Okay, and also has the quiz directions found at the end that we'll talk about here in a minute. Complete that. There's also then completed notes quiz review. So you can check your answers on the quiz as you do it without watching me and seeing the video. That's posted there. I'd recommend you go ahead. My recommendation for you is go ahead and do the quiz review on your own. Try it on your own. Check the answer. If you can't figure it out, then come back to the video. The video will be there with an explanation as to what you're going to do. Now, one thing I'm going to show you is I'm going to go to the link for the video for task 1, which is 13.4 trig applications. Okay, so when you click on this, you got the start of the video here. So if you click on the link and you get to the video, this is the video for 13.4 applications using trigonometry. One thing what I did do is down below at the bottom there's a description. It says Wanakey Online Geometry. Week 3, test number 1, names the video. Video details. If you click on show more, I did add to it, there is a time frame here of when some of the things start. And it actually looks like if you click on the time, it will take you right to that. So you can skip around in the video by using those. It's linked directly to that. So I will do that as well for the review by putting in on practice numbers like example number 1, example number 2, example number 3. You can click on those to see them and get from there to navigate around the video. So I would recommend you go ahead, do the review on your own, try it on your own, come to the video to answer any questions that you may have, and I will walk you through the problems there. If you're not sure on what you did wrong, you can follow the video along that way. But you don't need to watch the entire video to do the review. Probably be best if you try it on your own anyway first, see where you're at, and go from there. And then we will be taking the quiz. So in terms of grading, we haven't yet to determine, as in the videos made, how exactly your grade, the breakdown your grade will be. Homework will involve like some sort of completion as is. The quizzes will involve an accuracy score, so it will matter how accurate you get, and homework will discuss that, and we'll send a message out that details everything along those lines. But I will do want to stress that you need to make sure you're ready for the quiz, prepare for the quiz, and if you just blow it off, you're going to get a bad score, and it will reflect your grade in that way, because a score that does go into Infinite Campus will be reflected based on an accuracy for the quiz. So before you get off, I just want to go over the quiz directions here. Couple things with the quiz. Unlike the homework regular, once you start the quiz, you will not be able to return to complete the quiz. So when you click the start button, you can't go back in. You must finish the entire quiz at once. It is not resumable for you to go back in. That's different than our regular independent practice. Once you start it, you only have 2 hours to complete the quiz. Now you can start it at any point, but you only have 2 hours. There's a time limit. You should be able to complete it in under 2 hours. there are six questions on the quiz. It will be available to start Wednesday morning, 8 a.m., so it will not be open until Wednesday morning, 8 a.m. So do note, you can do everything to prepare up to that, but it will not be open until Wednesday. You'll then have Wednesday, Thursday, and Friday to complete the quiz. All answers on the quiz will be rounded to the nearest hundredth, 2 decimal places. We've been doing that pretty steady here since we've gone to our online. Everything in Schoology has been rounded that place. Instead of mixing things up, we've been consistent. Make sure you have your calculator ready and you set the mode to degrees. So if you go into your calculator, okay, I'm clicking on the mode, scrolling down where I've got my mouse is here, where it says degrees, that should be highlighted. If you are not in degrees and you are in radians, you will get all of them wrong. So make sure your calculator is set to degrees. On Schoology, it's the week 3 test number 2. It's the Mod 13 quiz. So in our Unit 5 Schoology Independent Practice and Quiz, it's the week 3 test number 2. Click on that and you will get started. So if I go to my Schoology page, you can see it here. So when I click on that, obviously my screen's a little different. Okay. Yours will look like this. So there's the directions again. Make sure you read them. Once you click start here, you have to finish it. You cannot go back in and come back out. So once you click start, you'll have to finish the quiz and you'll have 2 hours to complete it. So reviewing here for the quiz, I did add a couple extra slides. So if you do have questions on example 1 or 2, remember SOHCAHTOA. We always refer to, if we're talking about sine of A, cosine of A, or tangent of A, the angle is what we call the reference angle. I have it highlighted here, down here. Angle A is the reference angle for all 3 of these. Okay. Then the ratios involve sine is opposite over hypotenuse. It's the opposite leg over the hypotenuse. Opposite meaning across from the reference angle. The hypotenuse is always across from the right angle. Cosine, it is adjacent over hypotenuse. It's the leg that is adjacent. Okay? The adjacent leg over the hypotenuse, which is crossing the right angle. And tangent is TOA, opposite over adjacent. The opposite leg over the adjacent leg. So our first problem is use the picture to write each trigonometric ratio as a fraction. Well, the first column is sine of E, cosine of E, and tangent of E, which means all 3 of those problems, and make sure you look at what angle it is, okay, because they all refer to angle E as being my reference angle. So from there then, so sine is opposite over hypotenuse. Which side is opposite of angle E? Well, that's 21. Where's the hypotenuse? Across from the right angle, that's 29. So sine of E equals the ratio of 21 over 29. Cosine of E, ca, it is adjacent over hypotenuse. So cosine of angle E, my reference angle, which leg is adjacent? Well, that's ED, which is 20. That's adjacent. The hypotenuse is still 29. My ratio is 20 over 29. TOA, opposite over adjacent. Angle E is my reference angle. 21 is opposite, 20 is adjacent. It's the ratio of 21 over 20. The right column, sine of F, cosine of F, and tangent of F, all refer to angle F as the reference angle. So I did copy that picture so I can relabel it. Now I'm calling angle F the reference angle, which means 29 is still the hypotenuse because it's still across from the right angle. But 21 is now the leg that is adjacent to angle F, so we refer to that as our adjacent leg, and 20 is now across from it, it's now opposite. So if I want sine of F, it's opposite over hypotenuse, it is 20 over 29. Cosine of F is adjacent over hypotenuse. 21 is adjacent, 29 is hypotenuse, it's 21 over 29. And tangent of F, TOA, opposite over adjacent, 20 is opposite, 21 is adjacent. My answer is 20 over 21. That's example number 1. Example number 2, same type of problem. The only difference is we got a different triangle here. Okay, again, remember, we're doing what? SOHCAHTOA. The first column refers to angle R as my reference angle. 37 is across from the right angle. It's the hypotenuse. 35 is next to angle R, so that's adjacent. 12, the side that's 12 is across, that's the opposite side. So sine of R is the ratio of what? Opposite over hypotenuse, 12 over 37. Cosine of R, cosine's adjacent over hypotenuse. 35 is adjacent, 37 is the hypotenuse, it's 35 over 37. Tangent of R, TOA, opposite over adjacent, 12 over 35 is my answer, 12 over 35. Now if I go to sine of t, cosine of t, and tangent of t, angle T is now my reference angle. So that's why I made another picture down the bottom. 37 still the hypotenuse, but 35 now is opposite because it's across from angle T. And 12 is now adjacent. So the key, you have to identify the reference angle. Whatever angle they're talking about is the reference angle within the trig ratio. So sine of T is opposite over hypotenuse, 35 over 37. Cosine of T is adjacent over hypotenuse, 12 over 37. Tangent of T, TOA, opposite over adjacent, it's 35 over 12. So that's using our pictures to write trig ratios. The next one's going to look at some applications. Remember, for finding a missing side or angle, this is a copy of the flow chart. Okay, always start by drawing and labeling a picture. Sometimes they give it to you. Check to see if the Pythagorean theorem can be used. Given two sides to find a third. If not, then we proceed on. Ask ourselves the questions. What's my reference angle? From there, what sides am I working with? The opposite, adjacent, or hypotenuse. Which sides do I know? Which sides do I want to know? You're always going to involve two sides and one angle whenever you're using. And based off the sides, whether it's opposite, adjacent, hypotenuse, which trig ratio will you then use? Sine, cosine, or tangent. Set up an equation using the trig ratio we just chose, and then you got to solve it. Do note, if you are solving it, if we're going to solve for side, we will end up clearing fractions. Well, if we're solving for an angle, we're going to end up using the inverse. That's how I undo sine, cosine, and tangent. And then check to make sure your final answer is reasonable and that it works out. The next couple examples here, we're going to find some missing measures in some right triangles. We're going to round all our answers to the nearest hundredth. That is 2 decimal places, 2 numbers after the decimal place. So example number 3. What is my reference angle? What angle measure do I know? 40 degrees. So that's my reference angle. Which side do I want to know? That's X. The key thing is, which side is that? X, it's the leg that is adjacent to 40. Which side do I know the measure of? 19. And what do I know about 19? It's the hypotenuse. And the other side that does not have anything on it is the opposite side, which means nothing for us. But which trig ratio uses adjacent hypotenuse? Cosine does. So I'm going to write my equation. Cosine of the angle, cosine of 40 equals adjacent over hypotenuse, x over 19. Solving for a side, clear fractions. What number is in the denominator? 19. So multiply both sides by 19, they cancel out. I get x equals 19 times cosine of 40. Type that into my calculator. 19 times cos 40, close the parentheses. I get 14.554. Rounding to 2 decimal places is 14.55 meters. Example number 4. What's my reference angle? M. I don't know an angle measure, but it's the angle I want to find. So I'm going to refer to that as my reference angle. Which side do I want to know here? I don't want to know any sides. I want to know the angle. So instead here, I actually, which sides do I know? I know two sides, 10 and 26. 10 is adjacent, 26 is the leg that's opposite. The side I don't know anything for is the hypotenuse. So I'm using adjacent and opposite. Which trig function is that? Tangent. So what's my equation going to look like? Tangent of the angle, tangent of M, equals the ratio of opposite over adjacent. 26 over 10. Solving for an angle. How do I undo the tangent? How do I get rid of tangent? I do not divide. No, do not divide. I repeat, do not divide. We take the inverse. Tangent to the -1. We take the inverse of tangent. They cancel each other out. And that's going to leave you just M. M equals tangent inverse of 26 over 10. Because when I do something to one side, I have to do it to both sides. I have to take tangent inverse of both sides. Type that into my calculator. Tangent inverse. How do I get to it? It's second tangent. 26 divided by 10. I get 68.96. 2, which rounds to 68.96 degrees. Example number 5. Find the missing measure. What's my reference angle? Which angle do I know the measure of? 55 degrees is correct. Which side do I want to know the measure of? P. It's the side with the variable. I don't know it, so I want to know what P is. Which side do I know the measure of? 27. Well, how are P and 27 related to the reference angle? Well, P is across from the right angle. That means P is the hypotenuse. 27 is across from my reference angle. It's the leg that is across from it, so that's opposite. Which trig function uses opposite and hypotenuse? That would be sine. Sine of the angle. Sine of 55 equals the ratio of opposite over hypotenuse. The opposite side is 27. The hypotenuse is P, so it's 27 over P. Solving for a side. Clear fractions. Multiply by the denominator. The denominator is P. So I'm going to multiply both sides by P. They cancel out on the right. I'm left with 27 equals P times sine of 55. How do I get P by itself? Sine of 55 is a number. It's a decimal. I don't want to know what the exact decimal is. But how do I get rid of that number? Well, if it was 2 times P, I would divide by 2. But it's a decimal, so I'm going to divide by sine of 55. So using my calculator, I'm going to take 27 and divide it by sine of 55. And I put 32.960. Rounding to 2 decimal places becomes 32.96 centimeters is my unit of measure. Example number 6. Find the missing measure. What's my reference angle? I don't know an angle, but I want to find Z. That's my reference angle. Is there a side I want to find the measure of? No, there isn't. So I don't have to worry about which side do I want. Which does mean I don't want a side. There better be 2 sides that I know. I know the measures of what? 37 and 39. What's the measure of 37? How are they related? 39 is across from their right angle. That's my hypotenuse. 37 then is a leg. Which leg is it? It's the leg next to the reference angle, so it's adjacent. Which trig function uses adjacent hypotenuse? Yes, cosine. Cosine of what? Cosine of the angle means cosine of Z equals the ratio of the adjacent leg over the hypotenuse, which is 37 over 39. How do I solve for z? How do I get rid of cosine? Solve for an angle? The inverse. Take the inverse of both sides. Cosine inverse of cosine will cancel each other out and leave me with just cosine. Or you can leave me with just z. Sorry, leaves me with just z. Z equals then cosine inverse of 37 over 39. Type that into my calculator. How do I get to the cosine inverse? Second cosine. It's cos -1 of 37 divided by 39. Gives me an answer of what? 18.428, which rounding to 2 decimals, the 8 tells me to round that 2 up and make it 18.43 degrees is my answer. Example number 7. What's my reference angle? It's y. It's the angle I want to find the measure of. What side do I want? I don't want one, so I'm crossing it out. Which does mean I better know 2 sides if I want to be able to solve and find the measure of angle y. Well, I know 7 and 13 in the picture, right? Well, how are they related? 13 is across from the right angle. It's my hypotenuse. Where's 7? It's across from the reference angle. That's opposite. So 7 is opposite, 13 is hypotenuse. Which trig function uses opposite and hypotenuse? Yeah, sine does. Sine of the angle. Sine of y. Remember, it's sine of what is the angle measure equals the ratio of opposite over hypotenuse. 7 over 13. Again, we just did one like this in number 6. How do I get rid of y? Take the inverse. I take sine inverse of sine. They cancel each other out. Leaves me with just y. Y equals what? Sine inverse of 7 over 13. Type that into my calculator. Second sine of 7 divided by 13. You do not need to find that decimal. Okay? You don't have to find it. Just type it in as a ratio. 7 divided by 13. 32.578. Well, I'm rounding 2 decimals. That 8, which is the third number, tells me to round up. That means the 7 is going to become an 8. So my answer is 32.58 degrees. Example number 8. Find the missing measure. What's my reference angle? 62 degrees. Which side do I want to know the measure of? D. Which side do I know the measure of? 22. But how are D and 22 related? Well, they're both legs. The hypotenuse I don't have anything with. Well, D is the leg that's adjacent. 22 is the leg that's opposite. So I'm using what? Opposite and adjacent. Which one uses opposite and adjacent? Yes, tangent. Tangents. Tangent of the angle measure. So let's set my equation up. Tangent of 62 equals the ratio of opposite over adjacent. 22 over D. Solving for a side. I have to clear fractions. I clear fractions by multiplying by the denominator. The denominator, which is D. Multiply both sides by D. They cancel out. Leaves me just 22 equals D times tangent of 62. Gotta get D by itself. Remember, tangent of 62 is a number. How do I get rid of that number? Divide by it, because it's times. Reverse and undo. The opposite operation. So I'm going to divide by tangent of 62 to both sides. They'll cancel out on the left, which just gives me D. On the right, I have 22 divided by tangent of 62. Well, let's find out what the number is. 22 divided by tangent of 62 gives me 11.697. Rounding to 2 decimals. The third number is a 7. Tells me to round up. So I have to add 1 to this 9. If I add 1 to the 9, it's going to become a 10, which means I have to add 1 to the 6. Becomes 11.70, or just 11.7 yards. So even though it says 2 decimals, if that second number is a 0, you do not necessarily need to include it. So those are given a triangle, find the missing measure. Now the last 4 problems in the review are application problems. Given a story problem, you may have to draw a picture. You may be given a picture. So if you are in a hot air balloon here. You have a 500-foot rope attached to the ground next to your house. When the balloon is 450 feet in the air, the rope is now tight. The question is, what's the angle of elevation that your parents have to look up to see you in the balloon? Remember, angle of elevation is, here's your parents, is created by looking what? Straight ahead, then up. Right there is my angle of elevation. That is the angle that I want to find. That's going to serve as my reference angle. Are there any sides that I want to find here? No. Not interested in finding any sides. So I better know 2 sides. Well, I know 450 and 500, correct? Well, how do 450 and 500 relate? 450 is the leg that is the opposite of x. Well, 500 is opposite of the, there's the opposite of the right angle, so it's the hypotenuse. Because notice the height is straight above the ground. This distance down here is what we usually refer to as the ground distance. Don't need anything here. So we got opposite and hypotenuse. Which trig function uses that? Sine does. So when I set on my equation, sine of the angle. I don't know the measure angle. I want to find it. So I'm going to write sine of x equals the ratio of what? Opposite over hypotenuse. Which measures opposite? 450. What's the measure of the hypotenuse? 500. So sine of x equals 450 over 500. How do I solve for an angle? How do I undo sine? I do the inverse. Sine inverse is sine. They cancel each other out. Leaves me with just x. X equals, I'm doing sine inverse to both sides, so x equals sine inverse of 450 over 500. Type that into my calculator. I don't care what that is as a decimal. Sine inverse 450 divided by 500. And one of the biggest issues I always say, well, I don't care what is the decimal, because when you're doing it, unless you use the entire decimal, your answer will be off. Okay? If you round in the middle of a problem, your final answer will not be exact. Okay? We do not want to round till the end. So sine inverse of 450 over 500 gives me 64.158. Rounded to 2 decimal places, the 8 tells me to round up with the 5 and make it 64.16 degrees. Example number 10. From the top of a 100-foot lookout tower, so the tower here is 100 feet, a forest ranger spotted a fire at a 25-degree angle of depression. What's an angle of depression? It is created by what? Looking straight ahead. Remember, angles of elevation and depression are always created by looking what? Straight ahead. And then looking what? Depression means to look down, whereas elevation looks up. So right here is the forest ranger in the tower. Okay, so there's my angle of depression. When I get down to the ground, I can draw a line straight up here to create my right triangle. So I just get rid of those, you can see it. Now do note, there's my triangle, but I don't know the measures. But notice when I do draw a line straight down for the tower and straight on the ground, I've created a rectangle where opposite sides are the same measure. So the tower is 100 feet. which means this side of the triangle over here is going to be 100 feet as well. And the up on top is the ground distance is what I want to find, which is x. So do note the angle of depression is right here, 25 degrees. It's this angle right in here that I've just highlighted, okay? It is not the angle below, created by looking down and the tower. It's by straight ahead and then down. And that 25 degrees is my reference angle. I want to find the measure of x. Well, how is the side with the x on related to my reference angle? It's the adjacent leg. Okay? I want to find, I know the measure of 100 feet, which is the tower, which is the same as the side that's opposite of my reference angle. Which trig function uses adjacent and opposite? Yeah, tangent does. Tangent. Set up my equation. Tangent of the angle. Tangent of 25 equals opposite over adjacent. 100 is opposite. X is adjacent, so it's 100 over x. I'm solving. I have to clear fractions. Well, the variable's in the denominator. I still need to multiply by x. Because to clear fractions, I multiply by the denominator. So multiply both sides by x. They'll cancel out on the right. I get x times tangent of 25 equals 100. How do I get x by itself? I want to divide by tangent of 25. Tangent of 25 is a number. Divide by it. The tangent of 25 is on the left will cancel out. Leaves me with just x. X equals what? Well, x equals a number. How do I get that number? 100 divided by tangent of 25. Typing it into my calculator. 100 divided by tangent of 25. I get 214.450. Well, 0 doesn't tell me to do anything, so it's 214.45 feet is my answer. The fire is 214.45 feet away from the lookout tower. Example number 11. You're looking to hang a large banner from the roof of the high school. You need to know how high the wall is, but there's a bush in the way. You throw a 38-foot rope out to your friend, because you can't go straight down. We could drop a rope and measure it down, straight down, but it doesn't work for us. So we can throw a rope out to our friend who's standing away from the school. So throw a 38-foot rope out to him. She extends it out until the rope is tight, and then measures and creates an angle of elevation of 70 degrees. I want to know how high is the roof from the ground. Let's draw a picture. We need a picture first. So I need the school, right? So I've got the school here, right? And then you've got your friend over here. Your friend's over here. That point. So draw a line to the school. Draw a line that goes to the top of the school, which represents my rope. That's 38 feet. And I labeled the height of the school X. Right here's the angle of elevation by looking straight ahead, then up. Remember, straight ahead, then up? Well, that angle's 70 degrees. That's also my reference angle. Which side do I want to know the measure of? X. Which side do I know the measure of? 38 feet. And X is the opposite side. 38 feet is the hypotenuse. Which trig function uses opposite over hypotenuse? Sine does. So let's write our equation. Sine of what? Sine of the angle. Sine of 70. equals opposite over hypotenuse, x over 38. Solving for psi, what do? Clear fractions. Multiply by the denominator, which is 38. So multiply both sides by 38. The 38's cancel out. I get 38 times sine of 70 equals x. 38 times sine 70 equals x. 35.708. Which if I round to 2 decimals, the 8 tells me to round up and make that 0, have that 0 become a 1. 35.71 feet is the height of the school. So as long as the banner is less than that, you could hang it over. And the last example of the review is example number 12. Find the angle of elevation if you are standing 400 feet away from a skyscraper that's 850 feet tall. It's got a picture. So I've drawn my skyscraper, got the distance away, and that's where the angle of elevation is. Okay? It's also my reference angle. 400 feet, so my reference angle is x, what I want to find. The side I want to know, there isn't a side I want to know. Instead, I have two sides that I do know the measure of, 400 and 850. Well, they're both legs. They're both legs. Well, 400 is the leg that is next to the reference angle, so we call that our adjacent leg. 850 is the leg is the leg that is across from the reference angle. So that's my opposite leg. Which trig function uses adjacent and opposite? Yes, tangent does. Set up my equation. Tangent of x. Tangent of the angle. Tangent of x equals the ratio. Opposite over adjacent. 850 is opposite. That's going on top. 400 is adjacent. That's going on the bottom. Tangent of x equals 850 over 400. How do I solve for x? Take the inverse. Tangent inverse of tangent. They cancel each other out. Leaves me with just what? X equals what? Remember when I do tangent inverse, the left side to cancel out. I also do it to the right. Doing it to both sides. So x equals tangent inverse of 850 over 400. Type that into my calculator. Tangent inverse of 850 divided by 400 equals 11.996. Uh-oh. Sorry. There's a misprint there on my calculator. It's not 11.996. I did tangent inverse of 85 divided by 400. We've got a typo there, so I have to retype that in. I'm looking for tangent inverse of 850 divided by 400. See, you missed a number. It's huge. I forgot my 0. Off by over 50 degrees, almost 53 degrees, about. And it was 64.798. 8 tells me to round up with the 9, which makes it become 64.8 degrees. So that is a review of all the problems on the quiz review. If you can do all of those and understand them, you will be in perfect position for the quiz. Again, the directions for the quiz. Once you start it, you're not going to be able to go back in and return it. You must finish the entire quiz at once. You only have 2 hours to complete the quiz once you start it. It will be available starting Wednesday morning at 8 a.m. Round all answers to the nearest hundredth, 2 decimal places. Have your calculator ready and set to degrees. And on Schoology, it is the week 3 test number 2. It's called Mod 13 Quiz. It is in the folder with all the other regular independent practice. Okay? It's in the same folder as the independent practice. So it's just like doing an independent practice. The only difference is we're calling it a quiz. So the accuracy score will be reflected a little bit more. I will tell you one thing too in the quiz is there are some multiple choice questions where it asks which trig function, similar to the 13.4 homework. So if you haven't done the 13.4 homework, I recommend you go back and you do that before and check it out, because that's some of the questions on the quiz are exactly like you see in the 13.4 homework as you answer the multiple choice and then find and type in the missing measure. If you have any questions, remember, stop and see us during our office hours. We're here every day during the week, Monday, Tuesday, Wednesday, Thursday, Friday. Check Schoology for the hours. I am available every day from 1 to 1:45. Come join me. Come say hi. I miss seeing some of your faces. Some of you haven't talked to in such a long time. Just stop in and say hi. Be nice to see you. Nice to chat. And your teachers would love to see you as well. Remember, we are here to help you out. But in order to help you, you have to meet in the middle. We're out there in Google Meets waiting for you. You just need to come join us. So please join us. And if you have any questions, join us there. Send us an email. Touch base with us. And we will get through this. And we'll become better because of this whole circumstances that we're going through. Thank you and have a good day. Good day.